Good morning. I hope things went well yesterday with our simple interest lesson and practice. Today we are going to continue with our finance unit, and today's topic is compound interest. Okay, so the first scenario is the same one as yesterday, so we have Rachel again. But suppose this time that Rachel's grandparents leave the interest in the account so that each year the interest earned is added to the principal. Okay, so I'm going to kind of explain what that means, and then we're going to compare it to simple interest. So she started out with $1,000, if you remember. Okay, and the interest earned was 6%, so we multiply by 0.06. So it starts off that there is $60 in interest. So in total, she has earned $60 in interest. Okay, but this time, instead of her taking that money out, or instead of her receiving a check for that amount, we're going to leave it in so that the next year we start with $1,060 in the account. All right, and then this time the interest is not going to be 60 all the way through, because now we're going to calculate interest on this amount. Okay, so we're going to take the 1060 and multiply this by 0.06. When we do that, we get 6360. So now we're earning a little bit more interest because we have a little bit more money in the account. Okay, so in total, these two, in interest right now, we have earned $123.60. Not we, it's Rachel. Okay, so now again, instead of taking this money out, we leave it in. Okay, so $1,123.60 is what's in the account to start year 3. Interest is calculated on this amount, so we take this number and multiply it by 0.06, and we get 67.41. Okay, so again, a little bit more in interest because we have a little bit more money in the account. So now in total, we have $191.01. Okay, and so we have all of that plus $1,000 in the account. We earn interest on this whole amount, so $71.46. In total, we have $262.47 in interest. Okay, all of that stays in the account. We calculate interest again on this amount. So 74. Okay, so now in total, we have earned $338.21. Okay, so you can compare that to the numbers from yesterday, where I'm also going to graph them again, and on the same graph so that you can see kind of the difference. So at the beginning we had 0. After 1 year it was 60, just like it was before. After 2 years, 123, 191, 262, and 338. So it's not quite linear, right? It's really, I'm doing a good job, going to grow like this. And hopefully we recognize from before that a curve like this is exponential. Okay, and if we look kind of back to what yesterday's looked like, it was 0, 60, 120, 180. 300. Wow, that was terrible. So, okay, maybe I try that again. It is linear and will continue to go straight, but you can see that the exponential one is going to, yeah, they start off fairly similar at the beginning, but it's going to take off and end up being a lot more money. So we can remember that simple interest growth is linear. Okay? So just like yesterday, I'm going to show you a formula for how we calculate compound interest. This was a little bit trickier than yesterday's, but I believe in you. 1 plus I to the power of n. Okay, so we have some new letters, maybe? No, these ones are the same. So A is your final amount. In dollars. P is your initial amount. Okay, I here is your interest rate. But what's different is that we have to divide this by the compounding frequency. Okay, so what that means is different accounts offer different compounding frequency, which means how many times a year interest is added to the account. Okay, so I've given you a little box here that tells you kind of what all of the words mean. We've got annually, semi-annually, quarterly. It just tells you how many times per year the interest is going to be added. Okay, N is still your time, but this is multiplied by the compounding frequency. Okay, so the time is still in years, sorry. Okay, the time is always in years, but now it is multiplied by how many times we're adding interest each year. So if interest gets added monthly, and it's for 2 years, it's actually going to be added 24 times, right? 2 years times 12 times a year. So that's what our N is going to be. Okay, our interest rate back up here also still needs to be in a decimal, by the way. That didn't change, I just forgot to write it. Okay, and time is still in years. Okay, so let's take a look at some examples. So we're going to start just by calculating some compounding periods. Okay, so this first one, we have 5 years compounded quarterly. Quarterly means 4 times a year. So the N that we're going to use in the equation is 5 years times 4 times a year. So our N is actually going to be 20. Okay. The next one, 18 months. So this is not in years. So you made a note, time has to be expressed in years. So first we've got to change that. How many months are there in a year? 12. Okay, so 18 divided by 12 is 1.5. So that's our time in years. And we're going to multiply that by the compounding frequency. Semi-annually means twice a year. So that our, not multiplying it again. So we have 1.5 times 2, so our N is 3. Okay, down here we have 2 years, already in years, that's great. So my N is 2 times my compounding frequency, which is bi-weekly, which means 26 times a year, every other week. So we get 52 as the N. Okay, so when you're figuring out what your N value is, make sure your time is in years, and then multiply it by the compounding frequency. Okay. Next, we're going to calculate the interest rates as they would appear in the formula. So we're figuring out what our I is. So we always start by writing it as a decimal. So we have 0.06, and we're going to divide this by the compounding frequency, which is semi-annually, which means twice a year. Okay, So we have 0.03. Next, 5%, we start as a decimal, and then we divide by the compounding frequency, weekly. There are 52 weeks in a year. Okay, and you get, a really small number here. There we go. Okay, lastly, for this one, we start with 1.75% as a decimal, and we divide by the compounding frequency. So quarterly is 4. Our I is equal to 0.004375. Okay. So you'll always have to calculate your N and your I before you go to the equation. Okay, I'm going to do 2 worked examples with you to show you the whole process together. Okay, so if we remember the formula, we had A, P, I, and N, a pin. So, we read the question, calculate the amount, so I don't know the amount, of an investment if $1,000, that's how much, that's my principal, that's how much is being invested, at 5%, I'm just going to go ahead and write that as a decimal, for 3 years. Okay. But it says annually here. So annually means 1 time a year. Okay? So I'm going to write this out just because we always should. But dividing by 1 and multiplying by 1 will give you the exact same thing. Okay, so my I is 0.05 and my N is 3. So now we're going to go to the equation. Okay, we'll plug in all that we know. So 1,000, 1 plus 0.05 to the power of 3. So I'm going to go through and write out all of our steps here. If you are using your cell phone as a calculator, I recommend doing the same thing, okay, just so that we don't get any calculation errors. And I have noticed a few of those. So we start with brackets. We do what's in the brackets first. So we have 1.05 to the power of 3. Our next step in BEDMAS, if we're thinking back to that, is we do the exponent here. So I've got 1,000. And then we do 1.05 to the power of 3. Okay? Make sure you're typing that into your calculator correctly. 157,625. Okay, and then our last step is multiplication. So I multiply 1,000 times this number here, and we get 1157.63. Okay, and if we were perfect students, we would write a therefore sentence. So therefore, the investment is worth $1,157.63 after 3 years. Okay, I'm going to do one more example where we have a compounding frequency that's different than annually, and then send you on your way, I believe. So, A, P, I, N. Calculate the amount of an investment if $500 is invested at 3% compounded quarterly for 2 years. So here's the important part here. Compounded quarterly. Quarterly means 4 times a year. Okay, so our I gets divided by 4. I divide, okay, and we get 0.0075. And our N gets multiplied by 4. So we are at 8. Okay, now that we've got all of the values here, we go to the equation. Plug in what we know. Oh, I changed colors last time, I think. 1 plus 0.0075 to the power of 8. Again, we do what's in the brackets first. Okay, so 1.0075. Then we do our exponent. Okay, so 1.0075 to the power of 8. Okay. I got a big decimal there. And then we multiply this number by the 500. And that's our answer. 530.80. Okay? So therefore, the investment is worth $530.80 after 2 years. Okay? So you're going to go to this practice now. Okay? Just a few things I want you to remember. Okay? When you're calculating your I, we do, what am I doing? Your I is your rate as a decimal divided by the compounding frequency. Okay, so maybe we do this one. So we start with 0.042, okay, and we divide by the compounding frequency. Biweekly is 26. Okay, so whatever that is. All right, you take your rate as a decimal and divide it by the compounding frequency. For question 3, you're calculating your N. All right, so your N is your time in years multiplied by the compounding frequency. Okay, so for example, this one, we have 30 months, so we have to change that to years first. Okay, and then you've got your time, so 30 divided by 12, is 2.5, and then you multiply by semi-annually, here means twice a year. Okay. Down here in this chart, there's a lot of questions. I recommend that you do them on a separate piece of paper. Okay, don't try and calculate it all in here. You won't have enough space. Okay, so maybe call them A, B, C, D, E and do it on a separate piece of paper. Okay, so your amount, remember your formula, 1 plus I to the power of N. To calculate the interest earned, your interest is your amount subtract the principal. Okay, so what you get is your final value, subtract what you originally put in the account, and that'll tell you how much interest was earned. Okay, I will post the solutions more timely today to these probably this afternoon. Okay, good luck.